In this video, we're going to talk about how you can add and subtract rational expressions. Now, this is the kind of the trickier of the two lessons, I believe, comparing adding and subtracting to multiplying and dividing. This is a little bit tougher, and I'll remind you why with some basic examples that you might remember from like 5th grade or whenever we learned how to do fractions. Now, if you recall, if I gave you a problem like 7 over 11 plus 4 over 11, that's not a problem because we have common denominators, and that's the key when you add or subtract fractions. They have to have the same denominator in order for you to combine the numerator. So if that does happen, it's no problem. You could just do 7 plus 4 all over the denominator 11, and then if you can simplify, and in this case we can simplify. You get 11 over 11, which is just 1, right? Now, what's not so easy is if I give you a problem like, let's say it was 7/8, and you were trying to subtract 5/12 from that. Now here we're in trouble because the 8 and the 12 are not the same. So what you have to do in cases like that is you have to find, what the least common denominator is. So you have to find the least common denominator, which is just really finding the least common multiple of the denominators. Right? So you have to find the smallest number essentially that both 8 and 12 will divide into, and when it's just numerical, you don't necessarily have to factor things all the way down to find them, although that would help. Here you might know the smallest number that both 8 and 12 divide into would be 24. So the LCD, the lowest common denominator for this example, is the number 24, right? So then you might remember, okay, you have to create 24 in both denominators. So what you have to do is supply each of the denominators with the missing factors that would make the denominator 24. So you have to multiply 8 by a 3 to make a 24. Now, in order to keep this expression really equivalent to 7/8, I have to multiply the bottom and the top by that missing factor of a 3. And then on this fraction, the 5/12, I'd have to multiply the top and bottom by 2 in order to make that denominator a 24. So really, 3 times 7 then, if you multiply those, would be 21 over 24 if you multiplied the 3 and the 8. And then I can minus 5 times 2 would be 10 over 2 times, or 12, would be 24. Now we're on easy street because I have 24's, the least common denominator on both. Now when that happens, I can combine the numerators, and in this case we're subtracting. So I would do 21 minus 10 over 24, which is 11 over 24, and I don't think we can simplify that anymore. So that would be our answer there. So that's essentially what we're going to be doing today. We're going to be adding and subtracting fractions, but we're going to be doing it with variable expressions. So we're going to start off with kind of easier ones and work on to some tougher ones. Let's do an easier one together. Example 1, we'll have two parts to example 1. A, let's take a look at 4 over 3 times x, and we'll try to add that to 5 over 3x. Now, you might realize right now why this is one of the easier examples, and that's because we're adding two fractions and they already have like denominators of a 3x. So what that means is I can just keep the common denominator 3x and I combine 4 plus 5 together in the same numerator, and 4 plus 5 of course is 9, and I'd have 9 over 3x. Now here, since I'm dividing 9 by 3, I can simplify that into 3 over x. If you remember from the last lesson, we can cancel common factors if possible, right? 9 is really 3 times 3, so I can cancel one of these 3's with one of those 3's, and we're left with a 3 over an x. So that would be our final answer for A. For B, let's do another one. Let's say we have 2x over x plus 3, and I was subtracting the fraction x plus 5 over x plus 3. So here And let's make that a little better looking 5. Okay, so here, once again, I do have common denominators. We have an x plus 3 and an x plus 3. So that means my denominator is going to be x plus 3. And what I have to do now is just combine these numerators. Now, this is a little tricky, and I made it tricky on purpose. I have to take 2x and subtract the numerator x plus 5. Now, what a lot of students do is they just go like this, and they would be incorrect. Because what you're forgetting here is I have to subtract the entire quantity x plus 5, and now that I have parentheses around the x plus 5, that indicates I will have to distribute that negative. So really what I have going on here is 2x minus the x, and also minus a 5 in the top, and in the bottom I have x plus 3. So 2x minus x is x, and then I'm stuck with a minus 5. So I have x minus 5 over x plus 3. Now, don't get cancel happy. If you remember, in order to cancel anything, they have to be common factors. And the factor of the numerator is x minus 5. That is the factor. And the factor of the denominator is x plus 3. You can't factor it into anything else. So they're not the same, so you can't cancel. Hands off. Let's go on to example 2. So here we go, example 2. Let's go to something a little bit more fun. Let's go 5 over 6x squared plus x over 4x squared minus 12x. Okay, now we're in a whole different ballgame. Right away, you might realize, okay, 6x squared and 4x squared minus 12 are not the same. And therefore, I can't just go 5 plus x. What we have to do is we have to find the LCD. And this is the toughest part about adding and subtracting fractions, is finding the least common denominator. Now, guys, the first step to finding the LCD is you have to factor the denominators. So factor each denominator. Okay, so that's what we're going to do first. In this example, 6x squared I can break into a 6 times an x, if you will. You could even leave it as 6x squared, that would be fine. In this second fraction, though, that denominator, in order to factor that, I think I can only pull out an LCD. And if I do, that LCD would be a 4 and an x. So if I divide 4x squared by 4x, I'd be left with an x. And if I divide negative 12x by 4x, I think I just get minus 3. So the second denominator factors into a 4 times an x minus 3. Okay, so I've done the first step. I've factored each denominator. Now that I have it factored, what I have to do is, essentially, I have to find the least common multiple of each factor. And this is kind of the tricky part until you get the hang of it. So what I mean by that is this. I'm going to first take a look at just the numbers that are in each denominator. So I'm going to compare the 6 to the 4. And I ask myself, what is the least common multiple of 6 and 4? What's the smallest number that both of those divide into? And hopefully you come up with 12. So let's write our LCD over here. So I'm going to start off with the LCD 12. That's the least common multiple of 6 and 4. So sometimes when I'm done with those factors, I move on by crossing those off so I don't get confused later. Now, if you notice, the second factor I have is I have x's. I have 2 x's here and only 1 x here. I have to think of what's the least common multiple for x times x and an x, or if you will, x times x might be better off left as like an x squared. So the least common multiple of x squared and x is really x squared. Another way of thinking about least common multiple, guys, is what's the smallest term that both of those divide into? I know I can divide x squared by x squared, and I can divide x squared by an x. So the least common multiple of the x squared and x is an x squared. Now, I'm done with all of the x's. The only thing left out of both denominators is a factor of x minus 3. So the least common multiple of x minus 3 and nothing else is just an x minus 3. So this 12x squared minus x minus 3, or excuse me, 12x squared times x minus 3 is my LCD for these denominators. So that's kind of the tricky part. Now, the third step, once you find the LCD, we're going to, step 3, we're going to multiply the top and bottom of each fraction by the missing factors of the LCD. That will make the denominator equal to the LCD. So let's take a look at what that looks like in practice in this particular example. So remember, we had 5 over 6x squared, right? 6x squared. And we were trying to add x over, let's write it in the factored form. We had a 4 and an x minus 3. So for this step, what I'm trying to do is I'm comparing the LCD to this denominator, and I want to make it look like the LCD. So in order to make 6 into a 12, I'd have to multiply by a 2. And I already have an x squared. I have an ugly x squared there. Let's rewrite that as a nice looking x squared. I already have an x squared to compare with this x squared, but it's missing an entire x minus 3 factor. So I'm going to have to give it the factor x minus 3. So I have to multiply top and bottom of the first fraction by a 2 and an x minus 3 factor. Now, I'm going to look at the second fraction. This guy has a 4. In order to make 4 into a 12, it needs to be multiplied by a 3. It's got only one x, so in order to make it an x squared, I got to give it another x. And it already has the factor of x minus 3. So I think if I just multiply the top and bottom by a 3x for that fraction, I'll get the LCD. So this is what we're going to do now. I'm going to multiply top to top, and a 2 times an x minus 3 times a 5, I can multiply 2 times 5 to get 10 times x minus 3, so that's my numerator, over, if I multiply all this stuff together, 2 times 6 is 12, I have an x squared, and I have a factor of x minus 3. Now what should happen here, guys, is that should be your LCD, and it is, so I know I've done that part correctly. Now, the second fraction, I need to multiply top to top. X times 3x is 3x squared for my numerator. And in the denominator, if I multiply the 4 times the 3, I get my 12. X times an x, that x times that x, gives me an x squared. And then I have an x minus 3. So I'm going to write x minus 3. Okay, check it out. I have common denominators. Now that those are common denominators, I can combine the numerators. So I can write this as 10 times x minus 3 plus 3x squared, all of that over my common denominator of 12x squared times x minus 3. Now what I might do, just to kind of make this look a little bit nicer, is distribute the 10. So I get 10x minus 30 plus 3x squared over 12x squared times x minus 3. And I think if we write that numerator in standard form, it'll look a little nicer. We have 3x squared plus a 10x minus a 30 over 12x squared times x minus 3. And we've just added those two fractions to get that result. Kind of tricky. Let's do another one, and it'll be our last example before you do your self-quiz. Let's call this one example 3. In example 3, we're going to do x plus 1 over x squared plus 4x plus 4, and we're going to subtract the fraction 2 over x squared minus 4. Okay, right away, you notice denominators are not the same. So what we have to do is get the LCD. Well, in order to get the LCD, guys, we want to factor the denominator. So in this case, the first denominator, I think I can write with an x and an x. And two numbers that multiply to make 4 and also add to make 4 would be just plus 2 and plus 2. In other words, that's just x plus 2 quantity squared. Okay, so the bottom of that guy is factored. X squared minus 4 is a nice difference of squares. That's x plus 2 and an x minus 2. So when I find my LCD, I'm going to look at each of the factors and find the least common multiple for each of the factors. So for this problem, my LCD, I have x plus 2 squared, and over here just one x plus 2. So the least common multiple of an x plus 2 squared and an x plus 2 is an x plus 2 squared. Both of those factors divide into x plus 2 squared. So that takes care of both of those. The only factor left is an x minus 2. So the least common multiple of x minus 2 and nothing else is x minus 2. So this is my LCD. What I'm now going to do is I'm going to rewrite my fractions, and I have x plus 1 over, let's write it in the factored form. I had an x plus 2 quantity squared for the first fraction. The second fraction, if I write it over, is 2 over, and then we factored the x squared minus 4 into the difference of squares, x plus 2 times x minus 2. Now, what I'm ready to do is I'm going to multiply each of those by the missing factors of the denominator to get the LCD. So this guy has the x plus 2 squared, but it's missing the x minus 2 factor. So I have to give it x minus 2 to the top and the bottom of that guy. Now, when I end up multiplying these, I'll get the LCD. On this other fraction, I have an x plus 2 and an x minus 2, but my LCD has an x plus 2 squared. So I need to give it another factor of x plus 2. So I'm going to multiply top and bottom by x plus 2. And we'll continue this in just a second. So now we're at the point where we have the lowest common denominator established for each of the fractions. What we need to do now is multiply together the numerators. So I have x minus 2 times an x plus 1 in this fraction over the LCD we wanted, the x plus 2 squared, times the x minus 2, right? And in the other fraction, I have to multiply the numerators, which would be a 2 times an x plus 2 over the denominator, which, keep in mind, I have an x plus 2 times an x plus 2. There's my x plus 2 squared that I need, times the last factor, x minus 2. So notice now we are in a great shape because these denominators are exactly the same. So I can combine the numerators. So if we do that, we're going to have x minus 2 times x plus 1 minus 2 times x plus 2, all in the same numerator over the common denominator, x plus 2 squared, times an x minus 2. Now what you still need to do is clean up that numerator a little bit. We need to expand this product of binomials. We have to multiply that out or FOIL it, right? So if I did FOIL that, x times x would be an x squared. Then I have to do x times 1 minus a 2x. If you did x minus 2x, that would leave us with a minus an x. And then negative 2 times positive 1 would be minus 2. So there's that all FOILed out. I'm going to distribute the negative 2 here to the x and to the 2 to get minus 2x minus 4. So minus 2x minus 4. All of that good stuff over the common denominator, x plus 2 squared times an x minus 2. Are there any like factors here? I think so. In the numerator, I have a negative x minus a 2x. That's going to be an x squared minus 3x if you combine those. And then the negative 2 minus 4 can be combined to get minus 6. So, oops, I don't want to do that. So I have that numerator all over the common denominator, x plus 2 squared times an x minus a 2. And so there you have example 3, about as hard as they're going to come for you in this section. Now it's time for you to give the following problems a try. Here's your self-quiz.